All right. Hi, everybody. So I'm Joan Pepin. I am VP of Security and Chief Information Security Officer for Sumo Logic. I'm not here at all to sell our product. We've got a bunch of people downstairs who are much better at that than me. I do want to very quickly tell you what it is that we do, because it will be relevant for the talk that I'm about to give. So we are a cloud-based, cloud-first log management and analytics service. We are currently collecting logs from customers all over the world. We're running entirely in AWS. To talk about scale for just a second, on a typical month these days, we're ingesting upwards of 1.5 petabytes of data. Our key management system has approximately 8 million keys in management. So when I talk about building a secure service at scale, that's the type of scale I'm referring to. And so that's it for the product pitch. So a little bit about me. I've been in security for way longer than I care to admit. It says more than 17 years. That's nice. That's being a little kind. I hold a patent in an anomaly detection system. I've worked in all sorts of companies, from healthcare, defense. I spent a lot of time in managed security services, close to 10 years. And I've been with Sumo Logic now for over 4.5. And so that's just a little bit about me. And so what we're going to talk about today are first some of the drivers for leveraging the cloud. I'm going to give sort of an executive overview about why it is that we want to go there. And then I'm going to talk about some foundational principles to guide your design in moving to the cloud. I am relatively fortunate working for Sumo Logic. When I came to Sumo 4.5 years ago, it was a green field, right? And we got to design things from the ground up and bake security in from the very beginning. That's not the case for a lot of people. They're moving to the cloud. They have an existing application or applications or infrastructure that they're moving. And so you might be in a different situation than I was. But these foundational principles are going to still apply, right? And I understand that God made the world in 7 days because he didn't have an install base. And so we were able to do some things very quickly that might take other organizations a little longer. But this is still the all-encompassing sort of vision of how I feel that you should go about doing that and how we've done it very successfully at Sumo. Then I'm going to dive a little bit deep into our actual security infrastructure. It's something that we're pretty proud of. We talk about it to our customers and our prospects, but this is the first time that we've presented the actual data flow sort of diagram to a public audience and really drilled down into what it is that we do. And so once again, understanding what it is that we do as a service will help you sort of understand as I talk about and the choices that we've made and the trade-offs and the decisions that we've made. Then I'm going to talk a little bit about best practices in operating in the cloud, some things that you should consider in your design. And then I'm going to wrap that all up with some Q&A. So first, let's talk a little bit about the growth of the cloud and the drivers of people moving to the cloud. These are some interesting statistics. I don't want to belabor it because we're all here because we're into the cloud, we're in it, we're moving to it, we're believers in one form or another. But these are still some very interesting statistics. So 20% of applications are built on cloud-friendly architectures and are ready for the cloud today. But by 2018, we expect close to 60% of total cloud workloads will be SaaS workloads. And cloud IT infrastructure spending is going to reach close to 55 billion by 2019, or almost half of the IT spending. And so the cloud is the future, right? The economics of the cloud are inevitable. I really believe that the days of businesses doing all sorts of things that are not their core competency are really coming to an end. Our business is providing a log management and aggregation service, right? An analytics service. We don't need people on our staff to know how raised the floors need to be or how many BTUs I can fit into a rack, or that doesn't do anything to help us deliver our service to our customers. That does not help us increase our maniacal focus on customer satisfaction. That doesn't help us bring features to market. That doesn't help us compete with our very strong competition in the market, right? So Amazon is there to provide that layer for us. And that has allowed us to build a very successful, very large-scale business in a very short period of time. And so that is the future. That's the wave of the future. It's already upon us. But there's a problem. And that problem is that we as a security community are not ready to secure that future. And I can say that with some confidence because we're not doing a very good job at securing the present, right? And we all know this. It's not even a dirty little secret anymore. It's on the front page almost every week. There's a media-worthy breach after media-worthy breach after media-worthy breach. You know, people are focused on some of the recent ones in healthcare and retail. I think back close to 4 or 5 years now to the Heartland Payment Systems was one of the first real media-worthy breaches with all those credit card numbers, right? It hasn't gotten any better since then in 5 years. It keeps getting worse. Now, some people like to blame this on the cloud. I read an op-ed in the Washington Post about 6 months ago that made my head literally like pop. Where he was blaming this recent healthcare breach. I don't want to shame any companies individually, but big healthcare company had a breach. And he was like, the cloud, the darn cloud, these kids need to get off my lawn with the cloud. And I did some digging because I come from sort of a hackish background, and I'm like, well, what are these guys actually running? You know, what database was this that got breached, and what kind of operating system was it on, and what kind of data center were they running in, and did this have anything to do with the cloud? And no, it didn't. The company in question, and I determined this by looking at their careers page, who they're hiring, they seem to be running Oracle on Windows and Exodus data centers. What's cloud about that? That's an extremely traditional application on an extremely traditional operating system in an extremely traditional environment, but it's being blamed on the cloud. So, first of all, there's sort of a marketing problem with cloud, right? When I say cloud, a lot of people think iCloud, and they think, you know, those celebrity nude pictures that, you know, they don't understand sort of the industrial scale of the cloud, but I'm digressing. The future's here, and we're not ready because we're not even securing the present. What's really sad about that is we know what we're doing wrong. If I talk to 100 security professionals and ask them privately, are you doing everything that you know you should be doing? Are you doing your security 101 fundamentals to secure your network and secure your data? Almost all of them are going to say no. We're not doing everything, not just everything that we could do, not just everything that's possibly available, not just everything that I can conceivably think of. Most of us aren't even doing all of our basics, right? And we know this. And there's all sorts of reasons. It's not our fault. I'm not blaming us. I think that we're probably, as a community, one of the most dedicated and hardworking communities out there in IT and across many professions. So it's not because we don't care. It's not because we're lazy. It's not because we're sloppy. It's because there are other pressures. There are business pressures, budgetary pressures, architectural pressures, which I'm going to talk about quite a bit, that are forcing us into these boxes that we are unable to secure. And so as we move, as we saw from the statistics slide, we're going there, right? The reason we're all here and this conference is so huge is because that's where we're all headed. But we're kind of careening off the path here because we're not even able to work in the paradigm we've got now, never mind this paradigm that's very, very different. This is where we are now. And I like to think of it as boxes inside boxes inside boxes. And as security professionals, we didn't really have anything to do with the design of these data centers. We didn't decide, hey, I want you to give me 2 span ports off of your core switch that will let me inspect maybe 10% of the traffic that flows through it. That wasn't our decision. That was the network architect. That was the guys at Cisco who designed that switch to have only 2 span ports of 100 megabits while 2 gigabits are flowing through the switch, right? That's not the security person's fault. It's not our fault that the accounting department says that once you buy a box, you need to use it for 36 months before you can buy another box. That's not our fault. It's not our fault that our applications are changing, our customers are changing, the demands on our business are changing, the loads are changing, the operating systems are changing. None of that is our fault. But it's our job to secure it. And we're not terribly involved in any bit of this process. This all gets built, applications are written, things are deployed, and then they turn to us and say, hey, yeah, can you throw some security on that? Not really is the honest answer, but we can't give that answer, right? That's not being a leader, that's not being a team player. So we have to do what we can. We make compromises all the time, right? And so this is the reality of where we're living, and we didn't have anything to do with it. But we buy into the hype. I mean, I know I did. I came from 9 years at a managed security service provider, and one of the things that we exercised in all the time was FUD, right? We tried to scare people away from the cloud. Oh my God, you can't do multi-tenant. Are you nuts, right? Because your data center in your office park somewhere is much more secure than people who run data centers for a living, obviously, right? But I bought into all of that. And so when I came to Sumo 4.5 years ago, I had this hidden agenda. I was like, this AWS thing, this is great for prototyping. This is a fantastic way for us to sort of prove a point, do a proof of concept. And then, of course, we're going to have to move into a data center. We're going to have to rent or colo or build one or whatever we're going to do, because that's the only way for this to be secure. And if our customers are going to be sending us terabytes and terabytes of their sensitive log data, security logs, application logs, logs that might have personally identifiable information in them, then it needs to be secure. Therefore, it will need to be in a secure data center. I love that term when people throw that, well, it's in our secure data center. And so I got to Sumo and I started to really dig into the stack that they were designing, and it's a relatively complicated stack. And I'm thinking about all the different types of clusters and all of the applications and all of the different users and services and all of the ports that are going to need to be open. And I'm thinking about how I can cram it into this sort of a traditional architecture. And I'm standing there at the whiteboard sort of day after day trying to think about this, and I'm realizing I'm going to need a huge operations staff. I'm going to need guys with clipboards running around all day, like hardening things, and it's going to be crazy. And I started to understand why nobody had ever been doing it right. Having been in the security field for a long time, I had developed my core philosophy, which it includes things like understand every service you're running, run every service with the least privileges, don't have stray packets on your network, understand what all the traffic is and make sure everything is explicitly whitelisted. Blacklists don't work. I developed all these really good, sound, philosophical security ideas, and I had this greenfield opportunity and I wanted to implement them. But I started to realize how incredibly impractical that would actually be, and how expensive that would actually be, and how prone to human error all of those configurations were going to be. And this whole time, our chief architect is talking about Amazon and the APIs, and he's really excited. And he had this bumper sticker on the back of his iMac that said, we love APIs, and was really into this Amazon thing. And I was just like, yeah, this is great prototyping. This is awesome. I can't believe that anyone would ever, build an application any other way. But we're not going to put customer data in this thing, right? I get that you love it, but I mean, let's be real. But then about 6 months in, it really hit me that what he was talking about was the way that I was going to be able to do all of the things that I wanted to do. And I had this moment that I can't unsee. Once I saw it, I couldn't unsee it. And I realized that Amazon provided for me this huge amorphous blob of power that I could warp to my will using the power of code. And it was this my world is round kind of moment, and I've never been able to unsee it. And I realized that all of these things that I wanted to do, that not only I couldn't figure out how to do in a data center, nobody has really figured out how to do in a data center, that I could do in AWS. And my opinion changed 180 degrees. I realized now that I could probably build something in Amazon that's more secure than I could do if we rented a locked cage in Exodus in a secure data center. And so I want to talk a little bit about what some of those principles are that guided me there. So less is more. Obviously, complexity is the enemy of security. Sometimes things need to be complex, though. Sometimes problems are complex and require complex solutions. Our stack is pretty deep. We do everything we can to keep it as simple as possible, but when you're dealing with that kind of scale, with that many different types of use cases, you're going to wind up with somewhat of a complicated application. So a focus on simplicity is key. Keeping that in mind, keeping that up on the whiteboard as you're designing. How do I keep this simple? How do I keep this minimal? Automation. One of the things that our chief architect said to me early on when I was talking about human error, he said, well, a programmer can make an error. A software engineer might make an error. But the program doesn't really make an error, right? If we get the program right, it will do the security configurations right every single time, because that's what programs do. We don't have to, the root cause analysis might wind up saying, hey, we committed some code we shouldn't have committed, but it's never going to say, well, yeah, this guy just forgot to check the box. He's going through a 200-point checklist on a clipboard, and he forgot step 22, right? And so that's a very different class of problem to troubleshoot and to remediate. Well, to troubleshoot, to actually find the issue, and to remediate the issue. So automation is something that the cloud gives us, that cloud infrastructures give us, cloud architectures give us, that is very hard to achieve in a traditional operating mode. And this one here is really the core. I say this at least a couple times a week in one meeting or another, is we need to do the right thing. When we think about our data flow, every time that data hits a node, right, as you're drawing out your data flow diagram, your flow chart, and you've got the edges and the nodes, every time we've got a node in that graph, we need to make a decision to do the right thing. If it's customer data and we're going to save it to a disk, we need to encrypt it. If we're going to send it over the network, we need to encrypt it. If it's going to be the input to another application, we need to sanitize it. If it's output that's going to be fed into another application, we need to sanitize that too. The fundamentals, right? The basics. Take the time to make sure at every step in your design that you actually implement those. And once again, that's something that we have the power to do in an entirely different way than we've ever had before. And so now I want to drill down a little bit. And I don't know how much that pointer shows up, and if everybody can see it. And we've got two sides here, and it doesn't really reach over there. I will do my best to sort of explain us through this map. So this is how I see our infrastructure inside of AWS. And this is what we call a pod or a deployment. And we're running a bunch of these. We've got 4 of them in production right now. Actually, no, 5 of them in production. 2 in US West, 1 in US East, 1 in Sydney, and 1 in Dublin. Each one of these averages, it says 1,500 instances. That's an average. Some of them are much larger. So we've got the Internet of Things. We've got all sorts of devices generating all sorts of logs, all sorts of machine data. And there's a huge ingest pipe coming in, and we're fronting that with Amazon ELBs. I want to tell a great story about Amazon ELBs for a second. Heartbleed, right? There are organizations that over a year later have not fully remediated from Heartbleed. The average time to remediation was close to 6 months. We were able to do it in 12 hours and 15 minutes. 12 hours was on Amazon. It took them about that long to patch all of the ELBs. It was a heroic effort. It was fantastic. We're a big Amazon customer. We were on the phone with them practically the whole time, like every hour. How many do you have left? How many do you have left? They finally told us about 12 hours after it was announced, they're all done. They're all patched. At that point, we used our GeoTrust APIs to revoke and replace all of our certificates, and we ran a script to rotate all of our user credentials. We were done. Remediation complete. 12 hours on Amazon, 15 minutes on us, done. So the data comes into the ELBs, and then we'll hit one of our 4 front-end nodes, Endpoints. We have an API endpoint customers can use for search. They can also use it for configuration, various other things. We have our UI, where customers can go, actually use our system, query the data, write reports, do all sorts of cool stuff. Those are a very small fraction of our traffic, though. 99.99 something % of our traffic is inbound. It's terabytes and terabytes and terabytes of logs coming in every day. Then we have our little admin interface here. This is a completely invisible network footprint. PCI scanning is awesome. Once a quarter, they do a full network scan. We give them all of our IP addresses, public, private. They can't even ping them. They don't get so much as an ACK back, right? Totally invisible. So then they have to fall back and actually do an application scan on these endpoints. So from a security perspective, this is awesome. No one can even see our network. Nothing here is directly connected to the internet. We're using the ELB as basically a proxy. So from a scoping and compliance perspective, there's nothing really connected to our production environment. If our employees are going to come in on the back end, they have to VPN in. We have a VPN cluster running in AWS. And then we have two types of Bastion server, one we call Hop and one we call Box. Hop is for our tech support people. They don't have actual back-end SSH access to the individual instances, but they might need to make configuration changes on behalf of the customer. Say we have an account owner and that account owner is fired or quits or passes away or something, and we need to make a back-end configuration change for the customer. Our support people can VPN in. They can log on to Hop, which has a CLI, which reaches out and makes changes to our configuration database, which we keep in DynamoDB. We're very considered about the Amazon services we use. We don't want to be entirely dependent on the Amazon infrastructure, but there's some cool stuff there. And so once again, is running a database like that, is a relational type of database, is that our core competency? Is that something we want to spin people up to worry about? No. So we let Amazon handle that. For our DevOps team, they will VPN in, and they go to a Bastion host called Box. And we log everything they do there. And once again, this is a nice separation. This is like a man trap. Now, their laptops are not in scope. Nothing inside our corporate headquarters is in scope for any of our audits, because it's not directly connected to production. Only the Bastion host is. And that is a great control for us. We log everything they do there. We have file integrity monitoring there, et cetera. So any misbehavior on the DevOps team, we've got one place where we can track it down. If their laptop happens to get a virus or something like that, I'm not terribly worried about its impact here because of that lack of direct connection. We don't allow SSH port forwarding or anything like that. It's just a straight SSH connection. That would then allow them to go into the back end and do some manual intervention, some cowboy work. We also here, though, on this Bastion server, run something that we've written called deploy shell. And this is a great command line tool that allows our back-end people to make all sorts of changes, restart services, do all sorts of awesome stuff that way. Now, here's some cool stuff that we do that is very hard to do in a traditional data center. I'll kind of walk through the data flow just a little bit. Switch sides. So the data comes in. I already did that, sorry. All right, so firewalls, IDS, file integrity monitoring, and key management. We'll talk about all those things. So every node that we run, when it boots up, it talks to Apache Zookeeper. Zookeeper tells it what kind of box it is, what cluster it's running in. From there, it builds an IP tables policy, a snort policy, and an OSSec policy, so that every single node that we're running has a host-level firewall, has a host-level IDS, and is running file integrity monitoring on all the configuration files, all the binaries. Not many services running in secure data centers have that level of protection. Once again, often you're dealing with choke point security. We put a firewall in a place in the network that we force all the traffic through, and we put all the rules there, and we have this huge rule base. Well, our rule base is conditional based on what kind of server you are. We use IP tables is great because it understands users, right? So we can lock all of our services down to a service user. We lock that service user to a service port. then we lock that port to only the other IP addresses for the clusters that it needs to talk to do its job. So there's no stray packets on this network. Then we build the snort policy to have that same set of rules, so that any packets that are out of scope that do wind up happening or are attempted are going to be alerted and logged, and we'll be aware, hey, something's trying to talk that shouldn't be talking. Being as how we're a log management company, it's great. We've got this great log management product that we use to watch all those logs. Then we run the file integrity monitoring, OS-sec. And that's scanning all the configuration files, all the binaries, feeding all of that back into our own private copy of sumo logic. We also use Amazon security groups, belt and suspenders. We've got all the IP table stuff, but that's mostly for outbound traffic. We want to make sure that a box can't talk out on ports it's not supposed to. We use Amazon security groups for inbound rules, right? Belt and suspenders. In the unlikely event, so these are all Apache Jetty. These are the only things that directly touch the internet, and even that's through the ALB. If there were a 0-day in Jetty, and that Jetty user were to be popped, and then he had a local privilege escalation exploit and rooted the box, took down IP tables, well, it would still have the Amazon security groups in place to prevent any lateral movement, right? So this is real defense in depth, and the type of stuff that's, once again, very difficult to do in a traditional model. I think I've covered everything there. Now, we'll talk about key rotation, key management. Obviously, encryption is very important to our strategy for compliance, for security, for our customers' peace of mind, for safe harbor of the data if anything were to happen. So, as our data comes in and hits our receiver, say today at 5 p.m., you sign up for Sumo Logic and you start sending data into our system. As soon as that data hits our front-end receiver, we're going to generate 2 keys on the fly. One for your raw data and one for the metadata. So all the data about your data, insertion time, what the source host was, whether or not it was syslog or over SSH and the host name and all of that. And the index. We index all this data, a modified Lucene. We take that index, take all the metadata, encrypt that with 1 key, and then we take the raw data, we encrypt that with another key. Now tomorrow at 5 p.m., because you're just absolutely loving the service, you're still sending us your data. We're going to generate 2 new keys, one for your raw, one for your meta. We're going to store them in what we call Vault. This was something that we built ourselves. This was, once again, we consider which AWS services we used, and we looked at managed HSM. There's 2 problems with managed HSM. It doesn't scale big enough for us, and it's very, very expensive. So that was a case where Amazon gives us the flexibility to build a really cool solution on our own. We put this in its own VPC under a totally different Amazon account from the rest of production. We encrypt the hard drive, and then we keep our secure key ring. So each customer, yesterday's data, today's data with different keys, all those keys go on an individual customer key ring. That key ring is encrypted with a key encrypting key, a KEK, and then that KEK is encrypted with 2 KKEKs, key encrypting keys. One for our DevOps team and one for management. So those are not kept anywhere in Amazon. Those are kept on TrueCrypt volumes on our employee laptops, which the bare hard drive is encrypted, and then there's a TrueCrypt volume. So anytime we need to reboot Vault, which is thankfully not often, or if we need to manually revoke a key, we need an ops person with the alpha key and a manager with the beta key both present. This gives us dual control and dual knowledge over the primary key material at all time and keeps those keys out of Amazon. So I can tell our customers, yeah, we trust Amazon, we love them, but we don't trust them with a capital T. They don't have the primary key material. If someone walks out with that hard drive from Vault, and they walk out with the hard drives in S3 that have all of the customer data, even though they've got the key ring and they've got the data, they still can't do anything with it, right? And so this is a fantastic story. Our customers love it, our auditors love it, and it's really helped sell the fact that we can do this in the cloud, and not only have we built controls in so that our employees can't see customer data without customer permission, Amazon employees couldn't see customer data either, even if someone walked out of the building with hard drives. I was supposed to keep clicking. So, some key takeaways from this. One of my favorite lines from an Eagles song, everything all the time, right? Automation and the power of these tools and APIs and the ability to do this allow us to secure every step of the chain, right? Every interaction we can think about, we can explicitly allow things and not rely on blacklists or enumeration of badness. We can scale as much as we want with this pod model, and we can meet all sorts of jurisdictional requirements. Really bad news for a lot of companies Tuesday night. I don't know if any of you have seen, but a European judge ruled that safe harbor is not valid anymore, right? Well, that sucks, but that's okay for us because we actually run a pod in the EU, right? We're running in the Dublin region. We've made sure that there's no cross-contamination. Our pods can't talk to each other. So anywhere where there's a jurisdictional requirement where data needs to stay in that region, no problem. We spin up, everything that you saw, that entire architecture is an XML file. We change a few variables in that XML file, we make some API calls, we boot that thing up anywhere in the world. Best of breed security stack, right? We're doing IDS, file integrity monitoring, log management, host level firewalls. We have the ability to integrate a very complete security stack. Most of it's open source. So my budget, our CFO loves me. How many CISOs have a great relationship with their CFO? Not many, right? The compliance that we're able to achieve, SOC 2, HIPAA high-tech, PCI DSS, ISO 27001, Cloud Security Alliance STAR. We're one of the most certified, audited, and attested cloud services in our space, absolutely. And we do that very cheap because of this model. And it's all automated. So some best practices. This goes back to my core security philosophy. Understand every application that you're running. Really know what ports does it use? What kind of I/O does it require? Is it okay to run this on the same box as another service or not? Does this need a dedicated instance? What are typical behavior patterns of this? What other applications are going to access this? What users are going to access this? Is this open directly to the internet? Is this entirely an internal service? Lock all of those down so there's no stray packets. Alert on anything that you don't understand. If you understand all the applications they're running, all the ports that you're supposed to be using, when those are supposed to be talking, what they're supposed to be doing, it's very easy then to alert on anything that's out of spec, right? And keep your false positives very, very low. Because literally, your machine is designed to do one thing, that's what it does. Anything that's out of that spec is worth looking into, either from a security perspective or from a performance perspective, or just from somebody made a mistake. Some developer built and then installed a service and they forgot to put the entry so that the firewall rules were created. So now there's a service that's spun up and it's not working right. Somebody out there in engineering cube is scratching their head wondering why their service isn't working because they forgot to put that line to open up the firewall rule. Understanding your application, understanding all of the permissions, lets you have a level of security and a level of tightness and crispness that, once again, you're very rarely going to see in a traditional data center. I worked in defense for about 18 months. I worked at a cleared facility. I had my clearance. They did all sorts of, they were very proud. When I started on my first day, my boss said, "We have not had a remote intrusion since the Morris worm." All right. They don't do all of this. So, zooming back up a level, this is one of my favorite little analogies. This is what I use on the non-technical people. This is what I use on the CFOs and sometimes even the CIOs. I say you're a charming but broke person, and you want to go into business, and you can entertain people and make some money. And so you get the idea that you're going to play three-card monte. This is an actual picture of an old-time three-card monte table. And so you get a little card table, and maybe you drill a little hole in it somewhere, maybe you don't. And you buy yourself a pack of bicycle cards, and you get your coin, all of that. You maybe have a buddy. You have one of your buddies stand in the audience, and he's going to be your shill, and he's going to make sure that the audience does things a certain way, and he's going to say things that you want him to say. And this is a decent business model. It relies on a lot of hands-on control. You built that table. You always know where the coin is. You know the cards. You folded them just right. You've got someone in the audience to help guide the customer interaction, right? So this is probably a pretty profitable business. But you're looking at the scale right there. That's how many people you can fit around that table. That's it. If you want to increase the size of your business now, you need to do it very linearly. You need to buy another table. You need to pay somebody. And he's going to need to take a cut, right? And your profits go down and down and down. Now they start ripping you off, right? And this is no longer the fantastic business it was when it was just you and one card table, right? And this is the way that I think of the traditional model of that we think of in security, right? It's only secure if I can see it, touch it, watch the blinking lights with my own two eyes. I need to be able to go down to the data center and have my hands on it. That's the three-card monte. We don't see this very much anymore. This was probably the most recent picture, and I scoured Google for a long time. I wanted a good picture here. You don't see this much anymore. People, obviously, are still making a ton of money on that general business model, but they're doing it in a very different way. They're relying on statistics. They're relying on math and the powers of scale, right? There is not, and believe me, there's still, we all know, there's plenty of control exercised in these institutions, but it's a very different kind of control. The gaming board won't let you, rig a slot machine so that it never pays out, right? It has to pay out. So you have to rely on statistics for the house to always win. You have to rely on that scale. And by giving up that hands-on level of control, by giving up that I can see it, touch it, this is my card table, these are my boxes, I've got the guy in the audience, I know this whole thing like the back of my hand, by giving that up and relying on algorithms and relying on statistics, you can take this to an entirely different level than what you had before, an entirely different paradigm. And that's really what I like to think. When I think about the cloud as a new paradigm, the sort of two images come to my mind. One I already talked about was the world is not flat, right? And then this is the other one. The difference between those two businesses that are inherently the same business model, but operating in a completely different paradigm. So, some key takeaways. As I said, world is no longer flat. This is a totally different ball game. One of the biggest mistakes, and I was talking to a gentleman here in the front right before the talk, one of the biggest mistakes that companies make when they move to the cloud, I hear this a lot, we're going to move workloads to the cloud. And on one hand, I think that's great, and on the other hand, I twitch. Because really, the last thing you want to do is a forklifter just tar up your application and untar it in the cloud. You're going to take all of your security problems with you, and you're going to introduce new ones because you clearly don't understand the model, the new model, the paradigm that you're working in, right? So embrace the cloud. Yes, it's a fantastic economic opportunity. It's an inevitable economic opportunity. But that's not the only thing about it that's different. You have a lot more power. You have a lot more flexibility. All of the things that scare typical CISOs about the cloud, right? Oh my God, it's so easy for my users to sign up. I can't stop them. It's so scalable. It's so customizable. And rather than let that freak you out, embrace it. Understand it. Pull a judo move on that and use that to actually increase your security. centralize your security in your code base, right? My job, even though our service is massively more scalable than the last one I worked for, is much easier in a lot of ways. And that's because I don't have to worry about dealing with both application security and the network security. It's the same thing. My network is in code. So now I don't have to, like, half the day I'm thinking about, oh, do we have a buffer overflow in our application, and did we check all of our bounds, and did we sanitize input, and then also worry about, oh my God, I've only got 2 span ports on my switch, and it's all one thing. All of my security is in one place, and that's our code base, right? So by becoming an integral part of the security development lifecycle, I can manage both things with one tool, and that is to be a big part of the SDLC, right? My team, and once again, greenfield, it helps that I got there early, but my team is involved in every aspect of the product, from the specifications all the way through the user acceptance testing. Any feature that gets built needs to have security unit tests. We need to make sure that all of our security rules and regulations and guidelines and principles are adhered to with every build. And we can focus on one place for that, and that's our code base. And finally, well, no, not finally, all things are possible with automation, right? I love to think about that we've got these million little robots running around there doing all this security stuff for us, right? If we've got customer data on a volume, for instance, we tag that volume as having customer data. When we go to turn that volume off, when we need sorry, word blank, when we're going to shut that down, we have what our chief architect calls the data-destroying robots, right? It tags that volume as needing to be scrubbed. We boot up a little micro instance that runs the scrub, right? We use the DoD 5220-22.m 5 times overwrite to scrub all of those disks. The box goes down, the EBS volume gets mounted by this micro instance. It scrubs all the volumes, and then it decommissions. That's the word I've been looking for. And then the volume can be decommissioned. We don't have a bunch of people running around, oh my God, I got to scrub this drive. When I was with a managed security service provider, we used to worry about that. And we had a guy who would sometimes like hit hard drives with a hammer and like run a magnet over them. And you know, it's just talk about the definition of a manual task that's been automated. And then finally, simplicity leads to better security. So that circle diagram that I draw, when I show that to other CISOs, and I've probably shown it to a dozen of them over the last year or so, there's always this moment of, it can't be that simple. You know, when you told me about your security stack and all the things that you do, I was expecting this really complicated diagram, and you know, you just drew a couple circles on the board. Well, yeah, I mean, that's really the way that we think about it. It is that simple, right? There's no need to make it any more complicated than it needs to be. And not only does that lead to better security, I have to talk about compliance too. It leads to much easier and more cost-effective compliance as well. Because auditors have a tough job, right? They just flew in on a red eye from some other customer that does something completely different for a living. They need to come in and understand your environment, understand what it is that what your business does, understand your technology stack, and then review all of this evidence that looks completely different than the evidence they got at their last engagement, right? So by keeping this design simple, by having all of this evidence automated, it makes that process much easier as well. We went through PCI DSS about a year ago. We're about to go through it again. And the same auditor had audited us already for SOC 2 and HIPAA High-Tech, so he knew our system pretty well. And he hands us what's called the technical testing matrix. And it was basically for more than 1,000 of our servers, we needed like 50 points of information. What's the operating system version? What's everything that's in your Etsy password and Etsy shadow files? What's all of your file permissions for these key this huge list of things that he needed for more than 1,000 servers. And he said, yeah, this usually takes people weeks. You know, this is going to be really painful. I said, why don't you go out to lunch? I sat down with a couple of our DevOps guys. We wrote a bash script. We logged into our Bastion server, got into our CLI deployment shell environment, and we took a CSV file of all of the boxes that he wanted to, the sample that he wanted to collect that from, and we hit push. And it went and ran that bash script on all of those boxes and came back with one giant text file that had all of that evidence. He came back from lunch and I handed it to him. Here you go, Doug. Whoa. So then he had to actually, and this is one of the reasons I like Doug, is he has a guy who actually could write a Perl script. They wrote a Perl script to parse out that and boom, fill out their Excel spreadsheet. So that evidence collection process, that usually takes weeks. And I could easily imagine if I had to collect that type of information in a traditional environment, I mean, I'd shoot myself, right? We were able to do that over lunch. And so, like I said, I'm not here to sell our product. I'm here to evangelize the idea of cloud security. If you're interested in our product, we've got a fantastic booth downstairs. It's very hard to miss. It's right there when you walk in. And starting real soon, there's going to be 2 really big dudes there. And so you might want to check that out.